Okay, welcome all to another SD skill session. Uh, so today we are going to cover a topic around binary search, and let me know when you can see my screen. Can you see my screen?
We can see now. Yeah.
Okay, awesome. Okay, so today we are going to cover 4 problems, and we will be using technique around binary search. And so let's get started then with our first problem. So first problem is find first in task position of the array in sorted array. So what the problem says that if I have a sorted array which could have duplicates, and if I want to look for a target 8, it should tell me from where it starts. In this example, it's 0, 1, 2, 3, and where it is the last position, which is 4. So that's what the problem. If there is no target, then if there is no target, then we have to return -1, -1. And we'll also try to follow a pattern here, generally which we would be, which we would try to do in an interview, like clarifying questions, test case, coding design, and then again testing. So we'll try to see if we can follow all 4 of them. And that's how, like in any interview, it is like that. It's expected in any interview. So any questions or clarifications or explanation? So here, what could be the clarifying questions? Anybody wants to pick a? Okay. So let's say, so one is like length of array. So length of array could be, let's say, let's try to pick what is mentioned here. So it is not mentioned. So we'll take the length of array could be like integer max length. Then
or it could be empty also, right? Or it could be an empty array also.
Yeah, input could be empty or null. What else?
So I would refrain on question number 2. One is still makes sense. I mean, that could be your error handling probably.
Second one, right? Yeah, correct.
Yeah, I mean, we should ask the question that it makes.
Can it be? Yeah, correct.
It makes your design change, you know. Or if it is like too big, you have to think something else, or too small, you can do some brute force and fine. But I think second is debatable. I would not ask.
Okay, that's good. While doing error, while doing validation, and
but I'm saying what I'm saying yes, we can ask that question to ourselves. Interior clarification question. I completely,
because in couple of interviews, I asked this question, and the interviewer told, "Don't even bother about validation. That is not even expected from this exercise." So even if I ask it, like, okay, but it depends on interview to interview.
Yeah. So sometimes here, like since they said clearly, if target is not found, return -1, right? Sometimes they say target is always present. If that was the assumption, that means that we always get valid inputs. and
So,
we don't need to check for validation in that case.
Yeah,
so
valid
let's say,
comment. I take back my comment. I think yes, it will be helpful to figure out if array is null, then what expected return. Yeah.
so because here it is mentioned, otherwise it could be another clarifying question. So what if target is not there or if it is not present?
Yeah.
Hey Aseem, quick question there. And for anyone can chime in. So when I saw this question, like you're saying, right, in this example, we are given the situation where what to do if target is not present. So if we are given these two scenarios as an example, right, in the beginning itself, is it still okay to, not ask a question? Because, when I looked at this question, I was like, pretty clear. Like, what is your take on that? Sometimes the problems can be very clear, right? Like from an algorithmic perspective, I'm
No,
sure
but
if
I
I would
think
start
it's,
thinking on that.
yeah, I still think it's good to repeat the problem as the way we understood, because I mean, like, at least that tells them that we are not directly going to coding.
Yeah.
So it just clarifies that this is the way understood. I don't see any questions because it clearly
Yeah.
said that if target is not found, which means that I can assume it can.
But at the same time, I feel like we should not ask the too obvious question, right? Because it seems like, the question, the problem right here say, okay, I give the problem, here's a target present and here's a target not present example.
Yeah.
And then if we ask like that again, that means, we might not like read the question completely.
Right.
Like, I feel like, I don't know.
Is it not like an interaction with the interviewer, right?
But I second Naga's comment. It's always like replay the question.
Absolutely.
So it's always like it could be like if it is an unknown problem, I don't know the solution. Then I want to replay and I need time to buy. So somewhere back in my mind, I can run a thread to explore the answer. But meanwhile, I don't want to show I'm blank. That's what like I try the strategy, like replay the question. Yeah, I also agree with the line, like too much obvious questions and asking again and again could be distraction to the interviewer, but once or twice, and most of the times interviewer only give one input. They will give only this input and tell, okay, this. These two things won't be present.
Yeah, got it. Thanks.
Okay, what else could be a question? And we have to also time bound ourselves. Like we should not be in this question section forever.
Could it be like there's only one number and there's no repeating number at all?
All repeating, right? Yeah. All target.
No repeating at all. So it's just like 1, 2, 3, 4, 5.
All unique elements, basically the left and right will be same, or first and last will be same in that case.
Yeah. Okay.
And how that question actually impact the design?
It won't impact.
Yes, it doesn't impact. It's just.
It's nothing, right? It is the same thing.
So basically,
the same index.
It could be a good case for test cases, where when I'll say if I have 1, 2, so when I'm jumping to test cases, that could be a good use case. Like if I have 1, 2, 3, 4, and if my target is 3, then answer would be 2, 2. And so this could be a good use case when I'm writing test cases. And if target is like this, then the output would be like this. And so when I'm writing test cases, I should be doing this stuff. And so it could be in the it could be in the questions or it could be in the test cases, either way. And if target is like 11, then answer would be minus one. So I think these are the good questions and the good test cases to get started.
Also, what if all the elements are same as the target?
All the elements, yeah, that's another good test case. Like let's say 1, 1, 1, then the answer would be 0, 3.
So Aseem, I mean, not related to that's a Jenny question. So what will be the interior feedback, or they will feel like that if we don't ask the quality question? Most of the question here are obvious with that, whatever problem statement they have given, and still we are asking them.
I don't think so he's asking, but he's trying to create the test cases, I think.
Yeah, so this is I'm asking.
Yeah.
I'm telling interviewer back, when I have this situation, this would this would be the expected answer, and during my code I will try to find actual.
Oh, okay.
But coming back to your question, like
yeah, I just want to hear that. I mean, how they will feel that if we do that.
It depends on interviewer to interviewer and situation to situation. In one situation, I was totally blank about question. I don't know. Then I just started with a lot of requirements to get by some time. If sometimes, let's say this question I have already seen and it comes in the interview, then I know a lot of things, what I can do. It's just a matter like how much I'm exposed to that question. That's what, like, it's my personal opinion. But like I mentioned, we have only given this and this, nothing else. And if interviewer is not expecting this, interviewer will directly say in the test cases, hey, don't worry about this. So then this would go away. Like sometimes interviewer will say, like, if they think I'm going in a totally different, I'm going in direction which could take a lot of times, and okay, for now, just don't worry about this and move forward. But in our case, let's assume I'm the interviewer, I'm expecting all these things if I'm taking interview. Okay, let's not with, so what is like a solution. What could be a solution in this? One obvious solution would be, so generally how I break this, I generally put like this: solution 1, just search, and so search, and it would be linear search, and oh my god, and what would the complexity? It would be like order of n. So doing a linear search, I can still find one solution. So this is my solution 1. And then if I'm exposed to a problem, I will try to put one more solution on the table using binary search, where I can say like it would be in log n. So generally, that's what I generally do. If I know, like, okay, one solution is linear, definitely the interviewer will say, okay, let's expose the binary search one, because that is good in complexity. So is that?
Yeah, I think so. Yeah.
When you decided, like, binary search, linear or binary search, at that time, would we also tell the interviewer that the runtime complexity there, or
I generally do that. So again, this is my, so I generally give, if I know, I generally try to bring all pros and cons on the table. For example, in this question, I know linear search would be always order of n, and the memory would be order of 1. And here again, the memory would be order of it would be order of 1. So sometimes it happens like solution 2 could be log n, but memory is order of n. So I give interviewer options like, hey, which direction you want me to go, solution 1 or solution 2? So I give options to the interviewer like, hey, what exactly you're looking for. Then most of the time they can pick any solution now. But I have to tell all pros and cons at high level.
Yeah, Aseem, I just to share my thoughts on that. So I agree with what you said. So one of the ways I also look at this is one of the reasons I'm trying to explore different data structures or different algorithms is kind of driven by my time complexity or space complexity. So to me it makes sense if when I choose a data structure, I also think about complexity there, because that is what's going behind the scenes for my decision, right? I mean, I won't wait for the code to define the complexity. Does that make sense?
Again, I will, so like I mentioned, I will only do if I know all the things. If I don't know, still I'll try to bring things on the table, which will
No, but when you bring things on the table, right? Like if you, for example, in this case, I mean, it's not like you just bring like, heap randomly. There is a thought process going on behind it, in your mind.
No, what I'm telling, like, if I don't know even the solution, it could be linear, heap, or something. I don't have any idea. I'm totally blank. That time I will take a different strategy.
I see.
So then I will try to take interviewer help, like in terms of hints, to see like what I can get some hints and explore things now.
I see. Okay. Yeah.
So here, let's say I'm the interviewer, I'll say, okay, memory wise, both are same. Runtime wise, binary search looks good. Let's do solution number 2. Okay, good. Then now I have to give, still I'm not at the coding step. Still with solution 2, I have to tell some more things like what I want to do here. So for example, I would say, so basically I have to split into 2 parts. One part would be, one search would be to find left, and the second search would be to find right. And that's how I will proceed now. So I think by this time I will ask interview like, are you good with this? Can I code now? And then I think I can proceed further.
Why do we need the second search again? Like once we find the first search, it's just like checking for the consecutive numbers, or like it's in the order, right? So once you find it.
So that's a good question. Let's say I told this approach only. Like so that's why I told like don't code. First tell your approach. Search for the left and then go to right. So then interviewer will immediately ask me if all your numbers are same, what will happen? So go to this example. So as soon as I search, so I end up doing a linear solution. I reached here and then this side and then I'm open.
Okay. Worst case is like will become open.
Okay. So as soon as so let's say I give this and interview asks me, then I will immediately now try to change my direction. Hey, why not I do a search on the right also? And then that's how now my agreement has been made with the interviewer. Okay, we both agree, okay, one is left and one is right. We don't try to mix them together.
Yep. Makes sense, yeah.
Okay, so a lot of good questions. Thank you. Okay, now what next? Now I think at this point I would like to code now. I'll say, okay, I'm already into almost 10 minutes into the interview, 10:50. Now it's good time to code before I run out of time. So now anybody wants to code this solution?
I can try.
Sorry.
Yeah, I mean, I could give it a try.
Okay. So you want to share your screen, or you want me to give control?
I think I'll probably have to rejoin the meeting if I share my screen, because I always like revoke the permissions. If it's okay with you, I can just code it right here on your lead code.
Sure. Give me a second then. Let me take this notes first. Which language you prefer?
Java.
Okay. First, I took this note. I have a solution here.
You were using Python, right? You switched to Java now?
Yeah. I have some reasons for that. I don't know if you guys are interested in why.
Oh yeah,
that's a question Naga has been asking Harif many times.
That's definitely an interesting question.
Yeah.
Which language to choose?
I got the sense. I did some interviews with Python, and I like Python a lot actually, but I kind of got the feeling that like some people like kind of look down on Python, or they like see it as kind of like a beginner's language.
Well, it's slightly difficult to understand, I would say.
Okay, Hanif, do you have control?
I think so, yes.
Okay.
Yeah, so the idea here, like with a binary search, just like the textbook binary search, there's no guarantee which...
Actually, just one comment. It depends on the interviewer and the job that you're looking for. If you're interviewing for a Python job, then use Python. But if in this case we've got Java. If you're interviewing for a Java position, you should stick to the language that you're interviewing for and not use Python. Or if you feel really more comfortable in Python versus say Java, ask the interviewer, is it okay to use Python instead? I'm a little more comfortable in that, and they'll say yes, yay, or nay at that point.
Yeah, just to close on that, like I think most of the companies I was interviewing for, it wasn't for like a language specific position, so they'd say you could use any language. But yeah, anyway, not to go too far down that digression.
Yes. Let's for now try to stick on the problem. And Hanif, how I thought of doing, you could take a different approach, it's okay. But how I thought of doing this problem was explain, when I told like go left and right, I also want to explain the biasness towards going left and right.
Okay.
By any chance, are you also doing the similar solution?
Yeah, I believe so.
Okay.
I guess we'll see.
Okay.
Yeah.
Because
so
I also want to tell the audience about biasness, about left and right. So probably, yeah.
Okay. Sure. Yeah, I think I can account for that also.
Okay.
Right. So what I was saying was, like, if we just take a textbook binary search, depending on how it's implemented, there's no guarantee that like whether we'll get the first or last element that we're looking for, the target. So we can actually write a binary search that will be guaranteed to always either give the first or the last element.
You want me to hold on?
Sorry. I thought, yeah.
Just a second. Give me the control one.
Yeah, should I just, is it Chrome? Should I just?
Yeah, Chrome. Yeah, I can open the Chrome.
Oh, I guess I didn't realize I had full control. Okay. So I'll probably write another method here to take care of the search. So we'll call it private, and it will return. So this one will just return the one index, whether it's higher or lower. And I'll call this like search helper, maybe. We'll take the same input array of nums and the target. And I'll also have a flag, which I'll explain, which will indicate whether I'm searching for higher or lower. So I'll just call it higher. Okay, so then I guess the boilerplate, just basic input handling, we could just check that nums is not equal to null. or nums.length equals 0.
You missed the F.
You can do that in the main function and just here.
Yeah, true.
Either way, it should be fine. Yeah.
Yeah, I guess I'll just do it here. We'll just return -1.
It's nums equal null. You missed the F.
Okay. Okay. All right, so now I'll do the iterative binary search. So I'll say int low equals 0. Yeah, low equals 0, high will start off as nums.length. And so now I'll also keep like a result variable, and I'll explain that, and it'll be -1 at first. Okay, so again, pretty much just the textbook binary search while low is less than or equal to high. So at every step we check that we will calculate a mid. And so, yeah, so
for the high index, you need to use -1 because.
Okay, yeah, thank you.
Mm-hmm.
Right, so, okay, so on that topic of coming from Python, so Python doesn't have the overflow error, but I know Java might.
Oh, okay.
So the formula, I think is it high?
Low plus high minus 1 by 2.
Low plus high minus low by 2.
High minus 1.
High minus low by 2.
High minus low over 2. Like that?
Mm-hmm.
Okay. Yep. So that'll be our mid. And then we have like 3 cases. So if nums of mid equals the target. Okay, so here, normally if we find, like in just an ordinary binary search, so if we find the target, we could just return it here. But in this case, what we'll do is we'll say that result will equal mid. And eventually, this result is, I believe, what we want to return. So I'll just add that now. And now, let's say, just to like build up to the one that can handle both. So let's say that, forget about this Boolean higher argument. So let's say that this, I wanted to write a binary search with which biases towards always finding the first index. What I could do at this point is I could say that, okay, instead of breaking the search here, I can continue the search and I can set high equal to mid -1. Okay, so what that will do is I'll record the result that I found, and then I'll continue searching like the left half of the array. And then like if we keep going, then high eventually result will be the first index. So let me just fill out the rest. So else if, I guess we could do like high, okay, so nums of mid is less than target. So if it's less than the target, then we have to search the right half after the target. So then we could set low equal to mid +1. Else we'll set high equal to mid -1. Okay, so as it's written right now, since
it should be the other way around when num is less than target.
Yeah, I guess the order matters, right? Aseem? Like if we're biasing towards.
No, what I was asking, like if num mid is less than target, that means my high should become less. High should be mid -1.
Nums of mid is less.
No, I think it's good. I think it's good.
Yeah, nums of mid. So nums of mid is too low. So like you want to search in the higher. So
target.
Except I think it shouldn't be else if, it should be if. TLE.
else if T.
No, I think this is okay, right? But like, where are you using the higher?
Yeah, so I was So I was kind of building up to that. So like,
okay.
can we? So right now, what I'm claiming is that this should always give the first index of the target.
Mm-hmm.
Okay, and then if I similarly, so instead of saying if high, setting high here. Oh, sorry, I keep doing that. I guess the keyboard shortcuts are different because I'm using a Apple keyboard. Mm-hmm. So instead of doing it this way, so like I found my, I found that nums of mid equals the target. So I found my result, but instead if I kept searching and I set low equal to mid plus 1 here. So then what we're doing is we found the result, but now we're searching again in the higher portion of the input array. So then it would always like result after this finishes, it'll always give me the last index. Is everyone like clear on that? Like these two lines 14 and 15?
Yeah.
Because if so, then okay, then we can just combine these with our higher flag here. So we could just say if higher, meaning that we want to always bias towards finding the higher index. We'll take this one. Just use the mouse instead of keyboard. Okay, else. Yeah, I guess indentation doesn't matter, but okay. I haven't tested this, but I think this should work.
Now the main function, you just need
to
make
yes.
calls. Yeah.
Right. Okay, so let me scroll down there. Okay, so I guess we could do like our input guarding here as well. So what we can do is like we could say that int array result equals new int. And so this will be our default -1, -1.
Actually, you don't need to make, you just need two size, right? You are anyway returning -1 in the.
Yes, that's true.
Yeah, but it should be okay. Yeah.
Yeah, it should be fine. So I could do the same input validation, like if nums equals null, or
I would say it's not required, right? Because you already did it.
Yeah.
And,
Yeah, true.
You just make result of 0, one call, result of 1, another call, and then you just return the result.
Okay. Okay, so I could say result of 0 equals, and then I'll just call my function here. What did I call it?
Helper.
Search helper. Okay. Okay, so I'll pass nums, the target. And so in this case, I want to find the lower. So this will be false. Result of 1 will be search helper target and true. Then we can return result. Okay. Yeah.
We are done with the code step. I think the next step is our test.
Yeah. So I guess I won't use the lead code because that'll I mean, we could do that if you want to, but we won't have that in an actual interview.
So in the actual interview, we need to probably go through and try run it, right? To make sure that.
Yeah, we could try like manually running. Do you want me to do that, Aseem, or like should somebody else?
You can do, just take the example 1 and from the left.
Like this one? Oh, this
no,
one. Okay. Okay, yeah. So I'll just take that example that's listed there. So like nums is 577, etc., and target is 8.
Mm-hmm.
Okay, so first thing that we do is we'll try to find the first index of result, which is the lower index. So we'll call search helper with the nums, target, and false. So when we come here, okay, null, we just pass our validations. Nothing is, it's not null.
Mm-hmm.
So then we initialize low, high, and result, our usual way. Okay, so then our first iteration of the while loop. So mid will be low plus high minus low over 2.
Mm-hmm.
So, okay, so maybe I should say like on this side somewhere. So initially low will be 0. High will be the length minus 1. So 1, 0, 1, 2, 3, 4, 5, I believe.
Mm-hmm.
Result equals minus 1.
Mm-hmm.
Okay. And then I'll also keep track of mid here. So mid on the first pass will be, so high minus low is 5, over 2 is 2, plus 0 is 2, so mid is 2.
Mm-hmm.
Okay, so nums of mid in this case is 0, 1, 2, so it's 7, and our target is 8.
Mm-hmm.
So in this case, nums of mid is less than our target, so we'll take this branch, line 22, and we'll set low equal to mid plus 1. So then low will become 3. Okay, then our next iteration, so now high minus low is 2. 2 over 2 is 1. Plus, 1 plus 3 is 5. Or sorry, 4.
Mm-hmm.
So mid is 4. And then nums of mid is 0, 1, 2, 3, 4. Okay, so that gives me 8.
Mm-hmm.
So we have found the target. So we set result. Set result equal to the current index, which is 4. Or sorry, 4. And then so higher in this case is false. So we'll set high equal to mid minus 1. So high will become 3. Okay, then our next iteration, so midpoint will be 3. Nums of mid is 0, 1, 2, 3 is 8. So then we come here to this branch. We set result equal to mid, which is 3. And then we'll set high equal to mid minus 1 again, so it'll be 2.
Mm-hmm.
That'll be our last iteration, and then we'll break out of the loop and return result, which is 3. So that will be the index of the lower portion. And then so we'll call it again to find the higher one with our flag equal to true.
Mm-hmm.
So I could step through that one real quick also. So low is 0, high again will be, what is it, 5, right? And then result initially will be minus 1.
Mm-hmm.
So first time around again, mid should be 2, I believe. Right, 5 minus 0 over 2 is 2, plus 0 is 2. And so nums of 2 is 7 again. So that will take us back to this branch where it's less than the target. So we set low equal to mid plus 1. So low will become 3. Okay, next time around, mid should be 4.
Mm-hmm.
Now nums of mid 0, 1, 2, 3, 0, 1, 2, 3, 4. Yeah, so it's 8, which is equal to the target. So we set result equal to mid, which is 4. And so now higher is true, so I'll set low equal to mid plus 1. So low will become 5, I guess, right? Okay, next time around, mid will be 5. And so now nums of mid is 0, 1, 2, 3, 4, 5. So that's 10. So 10 is, it's greater than the target. So it'll be our last case, line 23. So we'll set high equal to mid minus 1, which is 4. And then we break out of the loop and return result equals 4. And let's just make sure 0, 1, 2, 3, 4. Yeah, so 4 is the index of the last 8.
Mm-hmm.
So then coming back down, we just return 3 and 4.
Okay. Yeah, I think it looks good. We can do a run code and see. That looks good. Can you also put in the test case down and put the second example?
Yeah, so I guess it's just target equals 6 this time.
Yeah. Okay. I think we can submit and see all that. Okay, this looks good. Awesome. Good job, Hanif.
Thanks. So I can.
Yeah, I have a question there. If we is that is that valid to mention that if we find the first one, and if the index is not equal to -1, and then we can use that at the lower bound, the runtime complexity probably would be the same. But if we use it, then the search space would be smaller.
Yeah, that's true. So he's saying that if we find result of 0 is -1, in other words, we didn't find, then we don't have to go to the second search, and we can just return. So I mean, yeah, we can like.
Yes, it is optimization. So we can
just say like, yeah, if result 0 equals -1, we could just say return result, yeah.
Also, one more optimization is if the target is less than the first number in the array and greater than the last number in the array, so we don't have to run the search, right?
Right. But yes. I think it's these kind of, but the core part is done where we want to do any optimization can always come. Okay, let me take the control then.
Sure. Do I have to do anything, or can you do it on your end?
Yeah, I'm trying, but I think.
Okay, let me stop control. I think you should have it now.
Yes. So, but any other questions regarding the implementation apart from optimization?
Aseem, you mentioned that it's a biased binary search, right? It's kind of a way. Is there anything else you want to tell about that, or is biasing is only using this flag and moving the
mid? I can show you. where how I did that, and then I found like that could be useful in other problems as well. So I split into two different parts, bias towards left and bias towards right. So that was my implementation. If I want to find first, so that's what I did. So I always, if I want to bias towards left, I always try to have I want to always have my high as my mid. So that's why it will always try to move as good as on towards the left hand side. And if I want to bias towards right, I want to take my low towards the right hand side or to the end of the thing. So that's what I did. But for that, I need to do one tweak here at line 36 to calculate my mid.
When would we would need to do that? Because sometimes I get confused. Sometimes, why we need to +1, and sometimes, why we don't need to +1 to find the mid.
So this is an example where we have to bias towards right. If you see, whenever we divide by 2, it is always if it is like 5, we always if it is like something like 3.5, we always take 3 because that's how integer is defined. But now I want to bias towards right side. If it is 3.5, I want to go towards 4. So that's why even I am not super sure, like if I remove this +1, it goes into infinite loop. And then I read some articles where they have mentioned, like, if we want to bias towards right, then you have to do +1 here. But
yeah,
sorry, and somebody wants to chime in.
I think because you don't want to keep, I think the reason it could go into an infinite loop is because like it'll keep, like mid will get stuck if you don't do the +1, I believe. Like it'll stay as the same value.
Yeah, it will try to do the same again and again. So this is one problem where I went biased towards right, but most of the problems which I did was always like biased towards left. Where the main thing to consider is, so how I understood is, if your target is greater than your nums mid, that is a sure shot, like my low should be greater. Like low should be mid +1. Otherwise, I always should have high equal to mid. And that's what we'll also see in our next problem. Why we want to be biased towards left.
So what about the case that we did, like Hanif did, which with low plus high minus low over 2?
This one, let's go back here. So that is also doing something similar. No, I think there we are not. Is Hanif? Can I call this is biased, or it's just we are continuing our loop and keep on going towards left or right?
Yeah. So two things. So the mid calculation here is just to like avoid overflow, and then what, like the logic from 16 through 19, basically like we're just continuing the search instead of breaking the search, and like we're continuing on either the left or the right part of the array. I think I have to like look more, but I think if you look at lines 22 and 23, so you can write those in either order, but I think depending on the order that you write them in, like whether you search for mid or low, that might also bias the search, but I'm not 100% sure on that.
I think like 20 to 23 we can write in any order. It's just because we already
yeah, in this case we can. The question was like the way we calculate mid, because there's a couple of, as you said, one is left bias, the other one is right bias. I was thinking if this one has any bias towards it, probably.
So here, how I take this, here we are
line 12.
here we are not doing any biasness. We are doing just a binary search. If I get my target, I'm still want to continue further towards my right or towards my left.
Yeah, depending on the flag. Yeah.
Yeah, depending on the flag. I just want to go further and further till I keep on getting the target. It's thinking that way. So in this example, let's assume my mid was this. I got my answer, but I still want to go further and further. That's it. And that's what Hanif has already recorded the answer here. If you see, the answer is already recorded here. And going towards left or right, if I'm not getting answer, it's okay because I've already recorded the answer. But in the other approach, which I was showing here, I'm not recording the answer. The answer would be found at the end when I was able to reach my either left or right. So basically here the answer would be recorded at the end when I'm able to reach this point. But in case of Hanif approach, he already recorded. So if he goes left or right and couldn't find mid, still it is, couldn't find target, still it is fine because he already recorded that. That's how I look into this, like differentiate between them. I did both ways. Still, there are a lot of points can be debated here.
Yeah. In both the cases, it's login. So
Okay, so it might be overkill, but once in one interview situation, doing this, interviewer asked me, what is your CPU cycles? So basically one CPU cycle is this. So basically interviewer was asking a lot of different questions, like how many CPU cycles a binary search will use if you check the mid here, or if you don't check the target or whatever I was saying. But that is overkill for this discussion. Like I can say like it's login, but after that also there would be a lot of things interview can go in and ask, like what are CPU cycles being used. But I think I would like to shelf the discussion here, and probably we have a lot other questions we can explore. We can see different things there.
Sure, sounds good.
Yeah, because I think there are too many comparisons over here. So
yeah, either way,
more comparisons. Yeah.
Either way, I will recommend like try to solve at your end and see. But this is a good exercise where you can. The reason why I picked this question, like here, basically we need to think about biasness, and a lot of binary search questions I've seen where biasness factors comes in, like how you want to bias your search. Okay. Shall we proceed further? We are already like 2:25 p.m.
Yep.
Sounds good.
Yeah.
Okay. Okay, our next question is capacity to ship packages within D days. So basically, you want me to read, or you want to take a minute or two to read, and then I'll start explaining. Okay, let's spend 1 minute, and then Okay, let's get started. For the interest of time, I might not go into all the steps like I mentioned here. So but if you want, we can go we can go with the workflow, or we can directly just do a discussion. How you guys want it. Okay, no answer mean I can take my own call.
And let's discuss a bit. Aseem,
Yeah, this question is also tricky. So first, let's discuss.
Yeah.
Maybe test cases.
Yeah, maybe test cases. Yeah, that's also fine. Maybe test cases. That way we also know.
So, like mentioning, this kind of question is like first is like we have to understand what's going on.
Yeah.
Then all other steps will help if we know what's actually going on here.
Yeah, of course.
Yeah.
Okay, so the question is like this. If I have these, so these are packages are there on my conveyor belt, and I have to ship, and these are the different weights, and I have to ship them to from source to destination in a ship. And based on the days, I want to decide what should be the minimum capacity of my ship. So in this case, I have days. I have 5 days. So that means what I need to do is I have to tell what could the minimum minimum weight of my ship, so I can take these packages in 5 days. And that's what it's the answer. Like first did this and this, and the output is 15 based on this.
Yeah. Well, one thing is like I guess you immediately have a lower bound on the capacity of the ship, because it has to be at least 10 or like whatever the max is.
So that's as good as max. Like when he say minimum, that is actually what is the maximum thing I'm putting on the ship.
Right. So the capacity has to be at least 10, I'm saying.
So let's do in this way. I have infinite days. What should be the capacity of my ship to take? So that means if I have infinite days, I will take only one package on a day. What should be the capacity of my ship?
10.
Yeah, 10 should be fine, right, in this case?
Yeah, so answer is 10. Like if I can take one package per day. So minimum capacity should be 10, because otherwise I can't, that is the maximum weight of my packages. Is that clear?
Yep.
What if I have only one day? What should be the maximum capacity of my ship?
So you add all of them.
Yeah, so if I add all of them, I think it's 32. That means that is the capacity. That would be my answer. Is that clear?
Yeah.
Now we are based on this. If I have some different days, what should be the capacity?
So how I calculated the 32 capacity? It's
a sum of all of them. I think it's 32. We can see 3, 3, 7.
Is it given in the question that the max capacity will be the sum of all the loads?
Sorry.
So is it given in the question?
No, it's not given the question. I'm writing my test cases. So this is my test case 1. This is my test case 2. And then furthermore. So if my test case is if I have infinite days, what should we answer? It would be 10. If I have only one, then it should be total
55.
55. Sum is 55.
55, yeah.
Thank you.
That's that n times n plus 1 over 2.
Yeah.
And if I have some other day x, then now I have to find what should be my capacity.
But it has to be consecutive.
Yeah, and it should be consecutive. Yes, that is the main point. It should be consecutive. I can't send the packages in any order. Then it would be different questions.
Then we just sort it and that's it.
So, any idea?
I think you take the length of the entire weight, divide by, I mean, each day you calculate how many packets you can send and multiply it by the maximum weight, like 10 by 5 into the length of the array is 10, right?
Mm-hmm.
So each day you can say send at max 2 packets. If you have to send all the 10 packets within 5 days, I mean, best possible case. If I give you 5 days and 10 packets you have to send, so
what
all
you're
the
saying?
5 days you have to use, all the 5 days you have to use, and you have to send all the 10 packets.
Yeah.
So 10 by 5, you can do every day 2 packets you send. By the end of the 5th day, all the packets will be sent.
But I want to give the minimum capacity. So in that way, I might end up 9 and 10 together. So that means my ship capacity should be 19.
Yeah, it's like 10 by 5 into max weight.
We should have the weights in the order only.
I think we should go with example 2 because example 1 is already sorted and is
yes.
It's easier.
Yeah.
Yeah, this one.
So if I group them also in 3, so basically like let's put to this, to this, to this, and my answer is kind of
I
in
think
this
here
only.
it should be 8. 6 days you have 6 total number of weights to be sent is 6, right? 6
No.
elements are there in the array.
That is output.
No, length of the array, I'm saying weight array.
Sorry, 6. Yeah.
So every day if you send 2 packets, and if you take maximum weight of packet is 4, so 6 by 3 into 4 if you do, so 6 by 3 is 2, 2 into 4, 8. I mean, every day you can say, I mean, minimum weight should be 8.
No, but
I mean, it's not the minimum, like the you can go less than that also, but
no, but I have to give the exact answer.
So I think Shashank is tending towards the same, like the binary search way, right?
Yeah, exactly. Then you will go to the left and check to get the better. Yeah. It's about
So,
So we say one day we take them all, right? Can we try if we have 2 days? Then what would be the package size? How do we find out, like 2 days, what the size of the package size?
So that's what we want to. So I know so right now I know about this test case. If I have infinite,
yes,
and I know about this. Now after like 8x, I have to calculate.
Right. So we have like an upper bound and a lower bound. So we're trying to find the minimum capacity.
So at this point, sorry, go ahead.
Yeah, I was just thinking like we could try maybe, because we know like with the first example, like with the test cases that you've written. So if we have an infinite number of days, then we can use a capacity of 10. And then like the other extreme is if we have to ship everything in 1 day, then we would have to have a capacity of 55. So we're trying to like, maybe we can, because D is given, I guess.
All the days should be used, right?
So maybe average the lower and upper bound.
Yeah, I don't know actually. I was thinking that would work, but I guess D is given, so I'm not sure if it'll work.
It's a bit tricky.
Yeah.
I'm trying to bring an intuition of binary search. That's what I'm trying to do.
Yeah,
Like,
that's what I was thinking. Like maybe binary search in that case between like 10 and 55 for something that would work, but it's D keeps changing, so I don't think you could do it that way.
so let's say what is my low here? So low is like if I have to send if I only one day, or if I have infinite days, how much I can send? 10, right?
Since we have the minimum capacity and the maximum weight, so we can do some. So our answer will lie somewhere in between, and just use some sort of binary search and find that with that the mid weight, whether we can actually ship in that D days or not.
Yeah.
If we cannot, and that will return that what will be the D for with that value, and based on that we have to actually change our range, whether we go with the high or low with that.
Yes, you are going the right track. Go ahead. Are you there?
Lost, it seems.
Okay, so I think, yes, I think the intuition is good. And I don't know who was talking, but yes, going the right direction. So if you see my low is over here.
And are you guys able to hear me?
Yes.
Yeah.
For me, the voice is breaking. Sorry.
Yes, Praveen.
Yeah, thanks for everyone.
So, so basically, I know. So in this case, I know like the low is 4. That is like one answer, and if I have infinite days, and if I have only one day, then the cumulative sum of all of them. So if I take a mid out of it, what will the mid here?
10.
10. So if I take how many packets I can take if my mid is, how many days it would take? So it will take 2 days, because if I accumulate some of this here, I can only take 10. Then it is 4, 5, 6, 7. If I add 4, it will become 11. So this will go in one. This will go in 1 day, and this other one will go into. So if I take mid 10, then how many days it will take? 2.
Yeah.
So 2 is lesser than my actual what I want. So that means I need to add more weight. So if I have to add more weight, I have to increase my mid. How I could do that? By changing my low. So what would be the new mid, new low here?
Maybe with the mid. 10.
10, and high would be same. It would be 16. Sorry, here I want to reduce my weight. Then I should get more packages on less packages on one day. That's how my days got increased. So basically, I want to have my low as it is, which is 4, and high will be
10.
High
Yes.
become 10.
Yeah, that makes sense. Because
And
you
mid now. Mid now is 7. So if I take 7, how many things I can take?
1,
I can
2,
this,
3.
3 days.
But
almost there.
Yeah. So in this case, my days are 3, but I want to go. I want to be more biased toward my left, so I'll go more further into that.
Okay.
So this time low would be 4,
yeah.
and high would become 7, and mid would become
5.
It would become 5, and if I take 5, still my days are 3.
No, 1, 2, 3.
It will change.
4 actually.
Yeah.
Days will become 4. So it's time. This time I have to change my low. This time the low will get changed. So this becomes on the higher side. So low will become
5.
5, and high would remain same. And what would be mid this time? It would be
6.
6. And what is the number of days here? It would be
3.
3. But I will still try to go bias towards my left. So this time my low would become
5.
Low is 5. High is 6. Mid is
5.
5. So we already did that earlier. So this would be D is
4.
equal to 4. And this time my low would become 6. High is 6. And this is my actually exit condition. So basically before that only I will exit it.
Mm-hmm.
And yeah. So these all questions have a pattern, what I have seen. And another next questions which will also do has the same pattern. You have to find the lower and upper bound, and then have to find a way of a count mechanism to see how you want to go left and right.
So you keep searching until you find the number of days that's given, and then you bias towards
left or right.
Yeah, bias towards left, right?
Yeah,
left.
Slow.
Lowest possible.
I want to go as low as possible.
Yeah.
I can show the code, which can be more clear, or somebody wants to write it.
Showing will be less time consuming.
So, so first of all, we have to find the maximum, right? So we can sort the weights, I mean, as a separate.
Mm-hmm.
And then we just get the last element.
No, we don't need to sort it. If I sort it, then I will.
No, I know. If not sorted, then we have to binary search for the max.
Yeah, but anyhow, we have to take cumulative. So basically, I can do a different method to cumulate and even do a max.
Yeah. Like the same loop, you can calculate the max and the sum.
Okay.
Yeah.
I can show the code.
That's okay. On the command, but does weight of.
So we'll come to this condition, but before that, we have discussed, first take the max value and the total sum.
Okay.
So low would be like my max value and high will be my total sum, like we discussed in example number 2. So that would be 4, and 16. Then this is a regular binary search biased towards the left side, where low should be less than high, and then I have a condition here. And otherwise, it will be this will make sure I'm biased towards my left.
Yeah, I was thinking of finding the maximum less than O of n, but I realized that we need to get the sum anyway, so it's going to be O of n, the worst case.
Yes.
Yeah. Okay.
And
so for binary search, it's like another thing. Like, so sometimes they'll say low is less than or equal to high, and sometimes it's just low less than high. So like, how do you?
So basically, I want to be biased towards my left. If remember, in between, I got the answer somewhere here, where I already got 3 days here.
Yeah.
But that was not the right solution for me, because the right solution was, I think, 6. And I want to go further, more and more towards my left.
Okay.
That would give me the good answer. If I stop there only, if let's say if I could have stopped here only, where if what I can say.
Yeah, I'm not saying to stop if we find the like an answer, but like just the condition in the while loop, like low less than high instead of less than or equal to high. Because I thought for like just for ordinary binary search, if you have it as low less than high, then like it might not work for a array of length 1, right?
Debate.
Yeah, it's true.
So.
Yeah, I guess when we return, I guess you have to just return.
I try to have the convertible as weight of window.
So this, what it's trying to explain, like this condition would not help here.
No, yeah, I got that part, but.
So I have also similar. Even I'm also still researching on that. But this is my interpretation till now. How I look if I want to be biased towards left. I want something on my left side, which I'm sure, which I want to go really towards my left. The obvious condition which is here is if my count is greater than D, 100% I have to do low equal to mid plus 1. So basically first I find the condition where 100% I have to increase my low. Otherwise, try to have your high as your mid. That's what like is my interpretation by looking into these problems. If I'm increasing my low, that means I'm going more towards my right. So, but I want to be more towards my left. So first find which condition is most obvious. This condition is most obvious where my count is greater than D. That means my low should be is equal to mid plus 1.
So if we do high is equal to mid minus 1, then that will not work.
Then we are going, I think, into this direction. Then it would be like this. But if you see here, I can't return mid here. I want to go more towards left.
Yeah, that makes sense. Like, because because then you could miss, like in that else case, like from 22 to 25. So it's possible that you found an answer there, but you like don't know if it's the optimal answer. So if you exclude, like if you do mid minus 1, then like you could potentially be excluding
least weight capacity,
the correct answer.
Yes. And this is the one which I'm just doing to calculate how much can go in one ship if my make is this. And this will just tell me how much ships I need. Or sorry, it's just tell like how many days I need. There's a typo there. And if my days are going on the higher side, that means I want to add more weight. So, to reduce my days. Otherwise, I want to increase my days. If my count is less, is that clear?
Yeah, if it's clear, I have a question on the brute force. If we have only one day and then we take them all, right? But if we have 2 days, I want to find the intuition to, like, if we have 2 days, then how do we find what is the optimal package? Not going through the binary search.
So then I guess you could just count, like, once you have your lower bound and your upper bound, like instead of doing a binary search, you could just start counting up from your lower bound, I guess, to do the brute force. Like instead of doing a binary search.
It's maximum weight capacity.
Yeah.
Okay, I will try it offline.
Mm-hmm. But you would see similar questions in lead code where this pattern is used. And I did one question a while back, I couldn't find it now, but that was actually a dynamic programming question. But using this technique, it could be solved without using dynamic programming. So there are questions which are dynamic programming, but using binary search, we can achieve the purpose.
At first, it looks like greedy problem.
Yeah, it's actually kind of hard to like recognize this as a binary search problem. Like if we didn't know that it was.
Yes, I totally agree with that.
It's cool problem.
Yeah.
Okay.
Can we see the, just like if you have a minute or two, can we see the find ships count method real quick?
Sure.
Okay, yeah, I think that makes sense.
If there are no questions, then we can proceed further.
Yep.
So this is an interesting problem. Here we can use binary search, and there are other ways also solving this. So, but here the question is, if I have a n by n matrix, it is sorted row wise also, column wise also, and I have to tell the kth smallest element in the sorted order, but not a discrete. Like here, if I give k8, the answer is 13.
Heap all up.
Is the question clear?
Yeah.
So individually, the rows are sorted, and then yeah. So this one, I think, like there would probably be like a lot of clarifying questions you could ask, because it's like.
But let's assume we have given all this thing, like it's just the smallest, not the distinct element.
Does it also imply that the diagonal also sorted?
It would be, right?
I don't know.
No, it's not, because if you check row 2 and 3, it goes 10, 11, 13, and then 12, 13, 15.
Oh, yeah.
It's sorted to me. Look like
Yeah, 11, 1, 11, 15 is sorted.
Oh, you
and
mean
5 and
here's
13 also sorted.
It's sorted, but yes, it should be sorted because this would be greater than this. This would be greater than this. So yeah, looks like it will be sorted.
And what does it mean that the columns are sorted? Like, if you take some element, then the like one immediately below will like be guaranteed to be larger.
Yeah, if you go top to bottom, it goes from smallest to largest.
Okay.
And then left to right.
But they could all be same also, right?
So what ideas?
So brute force would be actually
put them in a list, sort them, and find the kth element.
Right. Yeah.
So can diagonal information be used that if it's, let's say, less than 15, then actually no, we are not searching for an answer. We are searching for the kth element. Okay, never mind.
You can
actually check the mid element or something, and I mean, if it is equal to that, I mean, if the mid element is actually it's a square, right? So if the number of element in the top left square is k or something, you can actually return that.
Shouldn't k be 7 to return 13?
Exactly. Even my point is that if it is 8th position, then we need to return 15, I guess.
15, yes, yeah.
Yeah, even I was thinking about that.
But it's saying like kth smallest.
13 is to
not
add
an
2
index.
twice, right?
Yeah.
No, it's not an index. It's not an index, but the 8th element, smallest. If you count the number of elements.
6, 7, 8. Yeah, 13th is correct. 8th element.
Yeah.
Oh, okay. Duplicates too. Okay.
Duplicate, right? Yeah.
Yeah. Okay. I got it.
So I see the second solution because I think the diagonal already sorted, so we can do the breadth first search. You know, start from 0, 0, index 0, 0. Yeah, and then we go like from the top, you know, to the left, right? We just go like the radius or the breadth first search, and when we count, you know, we see 8. We have 8 elements, and that should be the k.
I'm not sure like how breadth first search will
Okay,
work.
so let's say think about 0, 0, right? That's 1, right? And then the next breadth first search, next element will be 5 and 10, right? And the next one will be 9, 11, and 13. Okay, we write out, then the next one will be 5 and 10.
So we're okay.
How about this?
So what I'm thinking here that the total number of elements is n cross n. Now find the mid dividing by 2, and then convert that mid into row and column. And with that row and column, that will tell us that how many number of elements are smaller than this particular.
That's not true, right? I mean, let's say if it comes out the middle point is 11, then so it's not implied that so if you take the middle 11, then the 12 is not the element at the position of 12 is not necessarily going to be bigger than 11, right? It could be even 9. No, it can't be 9.
Of time, the topic is binary search. I will try to forcefully take towards binary search.
So maybe use a sort of merge sort approach.
Let's come. So anyhow, there is one heap solution also, which is also good. If there is time, I can explain that, which could also be used, but we'll stick to this binary search topic. Because the next question, this one, could not be done with heap. That has to be done with binary search. Otherwise, there is a TLE error. Otherwise,
Hash map you can use.
Otherwise, this kind of questions could be done with the heap also, if you see the property.
Right.
First idea comes with heap only. Binary search, like, yeah, that also can come because it's sorted.
Yes. So, okay, let's say, what is my minimum element in this?
1.
What is my maximum element in this?
15.
So if I have, so again, coming back to that same concept was just in the previous question. If I have only, if I want one first distinct element, then my answer would be 1, like first element. If my k is 1, sorry, if my k is 1, then answer would be 1. If my k is 9, what would be my answer?
15.
So this gives me the bound. Like my low is 1 and my high is 15. And what is my mid now?
8.
Okay, so now can I do this something like we did earlier?
Yeah. So we can find the index for that.
So how many elements here which are lesser than 8? 2. Here nothing is low. Here nothing is lesser than 8. So basically my count is 2. Now that means my count is 2. I want to have more things in my. So count is lesser than k. That means I have to increase my low. So I have to go towards the higher side.
But how do you determine the count is 2?
I went row by row. This row, this row, this row. I went all the rows.
I think first of all, the matrix is not sorted. We need to sort it, I guess.
Which thing is not sorted?
The matrix is not sorted, I guess.
It's just the rows and columns are sorted.
It is ascending order.
No, the example is sorted, but as per the description, it's not necessarily sorted, right? It can be any order. I mean,
but it says the rows and columns are sorted.
I mean,
yeah, there's no condition that entire matrix is sorted. It's just
no, not the entire matrix. Only the rows and columns are sorted in ascending order.
Yes.
Yeah.
Yes.
So
sorted a row and a column.
So I think you are saying we should just compare the first element of each row and then find out whether the k matches or not, right?
We have to find kind of, or I have to see 1 is less than 8, good. 5 is less than 8, good. Stop. Go this row. 10 is all. So I'll stop here only. I'll stop here only. And then I got my count is 2.
Okay.
So now my count is 2, which is less than 8. That means I need, if I can't So this could not be my answer, which is like a mid. I need a better answer than that, where I have to increase my mid so I can accommodate more elements. So let's say if I make my mid as 8 and high as 15. Wait, it seems like I'm doing something wrong. If my count is less than let me check. Okay, so we have to come with the approach where either I have to go towards left or go towards my right. By looking at this, what do you think, like which side we should be going?
Right side.
Why? Okay, let's go towards right. So if I make my mid low as 8 plus it should be 8 plus 1 and high as 15, what would be my mid?
Well,
if I take 12, if you see, there's nothing I can have here. I have only, sorry, I have 3 elements here. I have 2 elements here. And I have, it's a total, I have how many elements?
6. Right?
7. Oh, 6, sorry. Yeah.
So 12 is inclusive.
12 is inclusive.
Without 12 too.
Yes. 12 is, yeah. So what would my count here? Count is 6 here. So still it is lower than K. So that means my mid should be more, should go higher next time. Then only I can accommodate more elements. So if I make my low as 13, high as 15, so what would my mid this time? Would be
14.
14. So how many elements I can accommodate this time?
All except 15, so
8.
8. So this is one potential solution, but like I mentioned, we have to be always biased towards left. I think here the biasness does not matter, but like how I coded it like a biased way only.
For getting the count when you get the mid, since it's row wise sorted, you can directly compare with the last element of the row. If 14 is greater than 9, that means it will never lie in the first row. 3 elements, you'll go to the second row, compare with the last element of the second row, again greater than 13 is less than 14, right?
Yeah,
But
either
that will
way.
be like again a binary search within each row, right?
Yes, we can even do that, but either way.
I'm directly attacking on the last element I was saying, because it's sorted. If it is less than that, yeah, it will be binary searching. Yeah.
So I'm just giving you an idea, but there are different ways. So the algorithm here again is the same thing. Find your, like what we did this time. We found the low, high, and now we are trying to find either go towards left or right.
No.
So so here the algorithm is like that. Then how you find this count guy is up to us. How optimally we can count it. I'm just giving an idea like how I did the counting. There are different ways to count it, but the algorithm is like this.
No. Okay. No.
So one more time, like how are you actually calculating the count every time? Like
oh, okay, Aseem.
So basically, based on my mid, I am trying to find in this row how many elements are less than 8. If my MIG was 8, so that means there are 2 elements which are less than 8. Otherwise, everything is greater than 8.
Right, but to do that part, like, are you doing just a linear search or?
I'm doing a linear search, but there are different ways of doing it. And so let's say, let me show you. And there was a link which I was looking, which has all the ways which we can do. And that was like a too much reading thing for me. Like I did like this, a linear way, but there are different ways of doing it.
Do you know if there's any like faster way than the linear search, or are they all like equal?
There are a lot of ways. Let me show you.
Maybe a binary search, we can do the same or no?
I think it'd be kind of tricky to binary search that though, right?
I've kept it linked somewhere. Let me try to find. Okay. So first time when I did this, I followed this link. On this, and then I can put that in the chat also. And then here that guy explained like different ways of doing this same problem. Here, this is for a different solution, but the person has mentioned like how you can do these all things.
Oh, nice.
So one is this sorted, like we discussed. Second was priority queue, and there are 2 different ways of doing priority queue using heap. And then that person mentioned about binary search based solution. This is the one we just discussed. And then this person also told zigzag search based solution. So, and then there's something like by select solution. But I don't know what that means. So, but like that's what I'm mentioning. Like doing the same thing could be there are different ways of doing it. We just discussed one way.
Yeah, maybe divide conquer also.
Yeah.
Write paper on this, like a college research.
Yeah.
I put that link.
Thanks.
So this was my solution, like how I understood based on the count. Take the count. If less than k, I want to go towards right. Otherwise, I want to stick towards my left only.
So count will again take order of n only, right? For counting the elements, we'll again traverse to the array, check.
So yes.
So what will the time complexity in this case?
Time complexity would be. Let me look.
N log n.
Yeah, I was thinking it's n log n.
Going to every.
Counting can be done in log
It
n.
have to be matrix.
Yeah,
The size of matrix log n something. Because n log n is not enough, right?
No, we are doing this count, right? Which is taking extra computation.
Yeah, but at the worst case, you have to count every row. Almost like that, right? Let's say with 0, all the arrays.
Almost n log n, that's what he's trying to say.
Yes.
And here, and n is the total number of elements, not right? It's not like the n as the like as in the n by n matrix, like the matrix dimension, right?
No, all the elements,
But we can use binary search to do that count. That will reduce time, right? Log n, can't it be?
Yes, we can do that. Doing this part, we can do in how we want to do it.
Oh.
But understanding this part itself was taking too much time for me. I didn't bother bother too much here, because doing with this kind of approach itself is a win. And
Yeah,
just
exactly. Yeah.
and optimization.
Yeah.
You made it very easy for us to understand. That's true.
Yeah.
But
Thanks.
but if it's I will take the heap solution first rather than taking.
Yeah, the heaps looks very.
It's easy also heap one.
Yeah.
What happens when the k is like count is equal to 8? We still keep going, you said, right? You were showing that example.
Yes, because I want to be biased towards the left, but I think in this case biasness is not needed, because we are looking for the exact count. So I think biasness is not needed, but I following the same pattern where I'm going this way.
So we were looking for exact element. I mean, exact element. Then we are using the non-bias approach, right? Low plus high minus low over 2.
Yes, I can stop where my k is equal to count equal to k.
Okay, and if we're looking for a minimum, then we go with the left bias. What about the right bias? Is it like last index of an element, maybe?
Yes, where I could have reached with my this condition count. But yeah, so this solution could be done with heap, but the other one, next question, I tried with heap, it didn't work because it is giving me TLE. Then when I did with the binary search, and that question is really, I think, a good candidate. The next, we will go to the next question. That is a good candidate for binary search.
Yeah, I think so. We should.
If you want, I can explain the heap solution. That is also interesting. Or we can go to the next one.
I have one question about that binary search, because we see the low is 1, right? And the high is 15 on the example. And we keep doing the mid, but at one point, the mid not going to be in the, in the matrix. But, somehow we still get the correct answer.
Even the first time itself, the mid won't be in the matrix. There's no guarantee mid would be in the matrix. But we are doing this kind of a divide and conquer. We are going instead of doing a linear one, we are just doing a logarithmic time, and it's as good as I think there are other questions also we do something similar, like finding the square root thing. We try to do half and then go left or right, again do half. So this is only doing dividing my solution into half again. Dividing my input set into half, either on the left or right. That's what I'm doing here. But there's no guarantee the mid would be in the array.
Could you share your problem? I think you are sharing that square root x, right?
Square root, that would be like a diversion here. I'm just giving.
Oh, sorry. Okay, I thought you were sharing that. Okay, sorry.
I was giving examples. There are questions like square root where we always try to do half and then keep on doing half. Like this is just one way of finding a solution where you don't want to explore all the inputs. You just do the half and then try to go left or right.
Mm-hmm.
I think let's proceed to the next one. I think that is again very similar to this one.
Binary.
Sure.
And I think in the handout, the question name is misleading, so ignore that. It is this one. So here we don't have any input array. It only tells like I have m equal to 3, n equal to 3, and k equal to 5, and tell me and how they have organized 1, 2, 3, 1, 2, 3, and then it would be like 2 to the 4 and 3 to the 6 here. So this 3 and 2 becomes here. And this 3 and this 3 becomes here. And here now I have to tell the kth smallest number. So the reason why this could not be done with heap, because every time I have to compute. But can I do without computation? So basically, can I solve this question without computing the entire table? That's my question. So they have not given the table. That is only for clarification purpose.
If the case, then we need to know what column we are in and what row, right? So we can implicitly compute it.
Which one?
I mean, not to generate the table, then we need to know what row and what column. What is current row? What current column?
Yes. So let's discuss this in a binary way. What is my low?
1.
And what is my high?
9.
So that is basically m into n, which is equal to 9. And so considering this, what would be mid?
5.
So now I have to find how many elements are lesser than my mid to decide whether I want to go towards left or right. So, and how I can do that? I don't have a table.
What I asked, can you repeat once more?
So now, so going back to the previous question, I need a count of in every row, how many numbers are less than 5?
Yeah, so I'm thinking like you'd have to have a couple for loops, like two for loops, and then like the outer is like would be like the left-hand side of the table, and then once you get to a number that's greater, then you can continue like that part, right?
Sure.
We always know the rightmost column. What the value of the rightmost column, right? Then.
So basically, yes, that is a good point. We know the value of the rightmost column. So basically, based on if I have to do a count, the count would be either n or so basically it would be either n, like all these elements are lesser than mid. Correct?
Yes.
How about this row? How many elements are lesser than mid?
2.
Can I say like mid divided by row number, which is 2? So basically I can go to each row. Here I can say minimum. So I can say min of n or divided by this. Can I say that this is a count for that row, and then I can keep on adding it. If this part is clear, I think then we can proceed further. And on top of that, I can have a loop for row
But in this
One.
case, we are assuming that the numbers are consecutive starting from the first one.
They
As
will.
you go.
They are not consecutive, but if you see the table is like this.
Yeah, but like what happens if we had a table starting from 5, then the second column would be 7 and the third will be 9.
Table, when you say table starting from 5.
Cái tivi của bác mà vô, nếu mà cái tivi của bác thì mà có YouTube á, ở trên tivi luôn thì bác vô trong cái YouTube.
I have muted everybody. If you want to speak, just unmute yourself.
So if it's 5, it's gonna be 5, 6, 7, right? What you're saying.
This table will start
from 1. So they give like M and N number. Yeah, basing on that, we need to create a table like starting from 1.
Yes. So there is no. That's what I'm telling. There is no table. So one way is first generate the table, but that was the extra computation. But what I'm trying to explain, we don't need to generate the table.
Yeah. Okay.
Okay. So that information you need to understand first. Yeah. Okay.
So basically, I was just telling the count thing. Here, my count is what is my count here? Final count. So count. So count was when mid was 5. The count was
6.
No, the count was 3, 4, 5, and 6. Yeah. And what was my K? K was 5. So basically, I want to reduce my count. Basically, I want to reduce. This time I will go towards my left, so I get a different bit, so I can have a. So what I need to do? What would be a low?
Low would be 1.
And high would be
4.
So what would be the mid this time?
2.
So number of elements here is 1. So this time the count is only 1. So basically this time I'll go towards the other side.
Right. Yeah.
And keep on doing in that way. Because we are already at time, so just share the solution so we can just look that.
Yeah, I think the binary search pattern is clear. I mean, it's like the same thing we've been doing, but I guess the key is that count calculation.
Yes.
Yeah.
Questions will have a different. So that's what I was telling here. This question is done with binary search. We don't need to even compute the table. But here the count is also very simple. But if I have to do with the heap solution, I'm as good as computing the next value.
But how did you come to that that formula, like count equals the min of n or?
Oh, I'm a good software engineer. I copy paste it.
That's a good answer.
Yeah, let's see. Like that part would be kind of tricky, like in just in an interview, right?
Yeah, intuitive is more like using 2 for loops.
That's what I was. I would have probably done. Yeah.
So what would be the interviewer response? When you kind of use 2 for loops, do they?
And
if a seasonal interviewer, that person will give you a hint.
Okay.
That's what I have seen. So yeah.
Yeah. In fact, even the previous problem, we're kind of doing 2 for loops, right?
Yes.
Yeah. I guess, but this one there's a trick.
Yeah. So how optimally we can go this part is one thing. So if you see, this problem is in two parts, coming up with this first and then coming up with this. So if I would be in the interview, I will say like, let me first do some magic here and first, or like, let's say like I will implement this little bit later and first let me complete this part. So at least this part should be okay and then I can come to this part. So basically so this is again good way of doing things in the interview where you divided your logic into two parts. So if there is a bug, that would be here only, but your one method is bug free. So this method would be bug free, kind of, but if there is a bug, then only this part would be effective. Okay, I think we are now over time. So if there are questions, we can discuss. Otherwise, we can break them.
Could you share your solution too?
Yeah, sure. That I'll do. I think we generally put that in a GitHub. Once I've pushed them, I will send you a link. Like I'll put that link in the chat in the Slack.
Thank you.
Could we talk about like 24 after stop recording?
Okay, let me stop the recording first.